Sanbonani guys, I hope that you're doing good. So this is lesson number 1 of RedOx Reactions, applicable to grade 11 and grade 12. Grade 10s are not doing this chapter. So let us go ahead and define what is a RedOx reaction. A redox reaction is simply a reaction that involves a change in oxidation number. So if there is a change in oxidation number in that reaction, we say it is a redox reaction. What is an oxidation number? It's simply the charge of an element or a charge of an atom. So now let us look at this reaction here. There is a change in the charge from 2 plus all the way to a plus. So this is a typical redox reaction because we can see that there is a change in oxidation number. When does this change in oxidation number take place? This will only happen when there is a transfer of electrons. And by transfer of electrons, I mean the gain or loss of electrons. Either way, if that is happening, if we're gaining or losing electrons, it's because they are transferred from somewhere to somewhere. There is a transfer of electrons. Now, let us go back to the word redox reaction. It is abbreviated from 2 words, red from reduction and ox from oxidation, hence redox reaction. So now, these reactions here that you see are known as both the reduction and oxidation because they are reversible. So going forward here is simply reduction and the reverse will be oxidation. So I will explain later how do you identify if the forward is reduction or if the reverse is oxidation. I will explain that. Now I say to my learners, if you understand reduction thoroughly, if you understand everything about reduction, this will not be a problem because you just reverse what is happening on the side. Okay, so we define reduction in 2 ways. We define reduction as a gain of electrons. Okay, as a gain of electrons. So now electrons which are gained will be found on the left hand side of the equation. So for instance, we can see that these electrons are on the left hand side of the equation. So these electrons are gained by this ion. Let us continue. We also define reduction in terms of oxidation number. So can you see that in reduction, the oxidation number is decreasing? So now, reduction is simply the decrease in oxidation number. The decrease in oxidation number. Now, let us continue. We can see that it is moving from 2 to a positive 1. So it is being reduced. Okay, all the way from 2 to 1. Let us look at an electron and try to think about it. In grade 10, you said an electron is simply a particle with a mass. Okay, it's a particle with a mass. So if a substance gains electrons, ideally it should gain a mass as well. So there is a gain in mass. Okay, when you gain electrons, you also gain mass as a result. So if you see a metal gaining mass, it is because it's simply gaining the electrons, okay, in this reaction, in this topic as such. So now a gain in mass means that we are gaining electrons, and it simply means that a substance is being reduced in a way. Let us continue. Before I continue, I want us to look at this diagram. This is called a cell, but to be specific, this one is a half cell. So what are the components of a cell? So a cell must have an electrolyte. An electrolyte is simply the solution with the ions. So a solution with an ions will conduct electricity, will allow electricity to pass through, and we call it an electrolyte. So in an electrolyte, we put a metal known as an electrode. So the whole setup is called a half cell because here we have one electrode. It's a half cell because we have one electrode. But if there are 2 electrodes in this solution, then it's a full cell as such. Now, This electrode can be found under reduction. It can also be found under oxidation. So the electrode under reduction, the electrode here, the electrode under reduction is known as a cathode. So that means a cathode is simply the electrode where reduction takes place. Okay, it's an electrode where reduction takes place as such. How can you remember the cathode? I usually write red cat. So red cat. So these animals are helping us now when we're doing chemistry. So cat abbreviated from cathode. So a cathode is simply a metal or an electrode where reduction is taking place. Also, we can try to remember this definition for the gain of electrons. I usually write just next to reduction, I usually write Reg. So what does Reg mean? So reduction is gain of electrons. Okay, Reg means reduction is gain of electrons. Red cat means cathode is an electrode where reduction is taking place. I hope that is making sense. Now, this is a reversible reaction. Like this, we call it a redox reaction. But when you're writing a reduction reaction, you can't include this reversibility sign. So you might be required to write down a half reaction under reduction. So the half reaction, why do I call it a half reaction? Because a full reaction is reversible and we call it a redox. So now when you're writing a reaction for either reduction or oxidation, we call it a half reaction. Now we said a gain of electrons, the electrons should be written on the left. So you can see that the fourth reaction, the electrons are on the left hand side. So that means our fourth reaction here is a reduction half reaction. So let us write this again. So this will be a copper 2 plus. A gain of electrons will always be on the left hand side. So electrons on the left means we are undergoing reduction because we are gaining electrons. And when we gain electrons, the oxidation number will be reduced. It will get smaller. So 2 electrons will neutralize that charge of 2 plus. This will now become a Cu in a solid. So now you no longer include the reversibility when you're writing a half reaction. And then again, we can write a fourth reaction here for silver, Ag plus 1 electron producing what? A neutral silver. So what if I were to add 2 electrons here? What would happen? If you have silver plus 2 electrons, 1 electron will completely neutralize this one. But if I gain another electron, this will become a negatively charged ion of silver. Okay? Why am I writing G here? So this, yeah, it is a G. So let us continue. Let us go over the other side now. As I did say, if you understand reduction thoroughly, the other reaction will be the total opposite. So now we define oxidation as a loss of electrons. So we're going to see a loss of electrons because the electrons would be now written on the right hand side. On the right hand side. If you write the reverse reaction, this electron will now be on the right hand side. And an electron on the right hand side means that the electrons are lost. So how can you remember the definition of oxidation in terms of electrons? Oxidation is loss of electrons. Write the word oil. So oxidation is loss of electrons. Now, if you are losing electrons, the oxidation number will increase. If you are losing the negative charges, then the oxidation number, the charge will increase and become more positive. Now, we said an electron is a particle with a mass. So if you lose electrons, it makes sense that you also lose mass as a result. Now, again, we said our electrodes can be found under reduction, they can be found under oxidation. But the electrode on this side, the electrode on the side is known as an anode. The electrode on the side is known as an anode. So the electrode is called an anode. Is called an anode. So how can you remember that this electrode under oxidation is an anode? You can just say an ox. This is another animal. We have a red cat on the other side. We have an ox on the other side. So N abbreviated from anode, ox from oxidation. So an anode is simply the electrode where oxidation takes place. Again, here we have a half reaction just like the other side. A half reaction. Remember, we said AMA reactions under oxidation have electrons on the right hand side. So if you can write this reaction in reverse, the electrons will now be on the right hand side. So that means the oxidation half reaction here will be a Cu in a solid producing a Cu2 plus 2 electrons, and we can write all the other reactions as well. So as we did say, electrons on the right hand side represent the loss of electrons, which is the definition of oxidation. Electrons on these ones are on the right, and then the electrons on the left hand side represent a gain of electrons, which is defining reduction. Now let us continue. So you will recall that on the other side of the board, we mentioned that if the electrons are on the left hand side, they represent a reduction, but if they are on the left, and then if they are on the right hand side, they represent oxidation. So now we have what we call a net ionic equation. So the sum of a reduction and oxidation reaction, it gives us what we call a net ionic equation. So the only condition there is here is that ensure that you have the same number of electrons for reduction and also for oxidation. So as you can see, we have 2 electrons here and 2 electrons here, so we are happy. Try to ensure that one reaction have the electrons on the left hand side being reduction and the other on the right hand side being oxidation. And if that is the case, these electrons will always cancel out. So the net ionic equation will only have what is remaining on the left hand side and what remains on the right hand side. So let me bring back my equality sign. Now, so what remains on the left hand side after cancelling the electrons? We have a copper 2 plus, which is an aqueous solution. What else remain on the left hand side here? I see a zinc, which is a solid, and then you go to the other side now to write what remains. So I see a copper, which is a solid. I see a zinc with a charge of 2 plus, which is an aqueous solution. So even from the net ionic equation, you can tell which element is undergoing oxidation and which one is undergoing reduction. So now the oxidation number increases from 2 all the way to 0 for copper. So the reduction or the decrease in oxidation number is reduction, and you did say copper is undergoing reduction. If you look at zinc, the oxidation number increases from 0, a neutral zinc, to a 2 plus. The increase in oxidation number is oxidation, and indeed on our reaction, zinc is undergoing oxidation. Now let's look at this one. I said the condition here is that the electrons must be balanced, so they should be equal. We have 2 electrons, we have 1 electron. If you know your math, you might be tempted to divide this equation by 2 so that you have 1 electron. So we try by all means to run away from division in a chemical reaction or equation. So rather, we multiply to ensure that the number of electrons is the same. So I can multiply this equation by 2, and by doing that, we're going to have the same number of electrons. Now, if I multiply the whole equation by 2, I now have 2 electrons and 2 electrons. And once they are equal, they will always cancel out. And then all that you need to do is to write what remains on the left, what remains on the right hand side. So what remains on the left, it's the 2Ag plus So a charged element is simply an aqueous solution, and then this is a Cu in a solid, so plus a Cu in a solid, and then this gives us what remains on the other side. We have a 2 Ag as a solid plus a Cu2 plus. So these are called the net ionic equations.